Hello and welcome to section 2.2, Basic Differentiation Rules and Rates of Change. So in this section we're going to be talking about some of the shortcuts that end up happening when we go through and take the derivative of a function. And so this is probably the where you're going to spend most of your time from here on out when we're dealing with derivatives. We try to, there's kind of a shortcut to the limit process when we're dealing with these, and we'll talk a little bit about that in class, and I'll try to explain it here today too. But if we were to take the derivative of a constant, we will end up with 0 for that. And if you want, you could do the limit. You know, if you said f of x was 4 and you did the limit process on that, you would find out that you would end up getting 0 for that derivative. So a constant rule, you need to make sure you know that. If you are, then what ends up happening is, as we were doing all these derivatives, as we were going along, you may have noticed something, a pattern that was forming, that if you started with a function like f of x equals x squared, and you took the derivative of that using the limit process, you ended up with functions like 2x, and that was the slope at any particular point of the function. Well, that becomes the general power rule that we're going to be using, the power rule, and that basically says if you're taking the derivative of a function, you can multiply by that power and reduce the power by 1. If you're dealing with a function like f of x, or just a equals x, well, the power, you're going to multiply by the 1 and reduce the power of x by 1. So if my function was x, and I asked to take the derivative of it, well, remember the power on this guy is 1, so I multiply by the power and reduce the power from 1 down by 1 to 0. Well, x to the 0 power is 1, so your final answer is you're going to have a slope of 1. And that should make sense if you think about what the graph of y equals x is. The graph of y equals x, no matter where you're at in that function, if I would have hit the 0, 0 spot, well, we'll move it, the slope of that line is always 1. And so that's really what we're talking about when we deal with these. So now we have a constant multiple rule, and basically what ends up happening with constants, if you had something like f of x equals 3x squared, this 3 is a constant, so we basically, what this rule tells us is that we don't need to take the derivative of the constant because it's multiplied by the function. But what we can do is we could take that constant out and say, oh, I'm going to take the derivative of the function with respect to x, but leave the 3 alone. So it's going to be something like this. And if I was to take the derivative of that derivative of 3x squared, I would leave the 3 alone, take the derivative of x squared, which is 2x, and then my final answer is going to be 6x. And again, remember, this 6x is the slope of the slope at any given point in the function of 3x squared. And so that's really what we're talking about when we're taking these derivatives. So then sum and difference rules don't change, and this is very powerful for us because where these guys show up is when we ask to take, say our function is a polynomial function, and we have something like 3x cubed minus 6x squared plus 12x, and whatever else. I could have a constant on here if I wanted. And so then basically what we would do is treat it, we would go through and treat this, what this is telling me is, okay, I've got all these functions added and subtracted together. Well, what I can do is I can go through and take the derivative of each piece as necessary separately when we're adding and subtracting. So I would, if I was taking the derivative of this function, I would take the derivative of this guy all by itself, which would be 3 times 3x squared, and then over here I'd have 6 times 2x plus 12 times 1, and then this guy is, remember, a constant turns into 0. So this right here, when multiplied out and combined, 3 times that, this ends up being 9x squared minus 12x plus 12, which this is the derivative, this is the slope at any given point in my original function. And so this is just sum or difference rules are just telling me that I can do each part separately and add and subtract them together as necessary. It will be different when we multiply. When we multiply them together, we'll talk about that in the next section. We multiply or divide them. So then we have the derivatives of sine and cosine, and so when we take the derivative of sine, we get cosine, and when we take the derivative of cosine, we get sine. And you just need to know them. We'll talk more about this in the future, but you need to know these. This is something that you need to memorize, and you'll use it so much that you probably don't really need to memorize it, but right now you probably do. So then, what we're talking about is all of the derivatives are used to determine slope. But other terms that we use for derivative are rates of change, because that's what slope is. It's a change in an x value with respect to y. So it's the change in, or the change in the independent variable with respect to the dependent variable. So what we're saying is, we're changing the population over time, we're changing production of something over time, and so these guys are some things that we use for the derivatives as considered rates of change. And you're going to hear so many different ways to ask for the derivative that you just kind of have to get used to it and think, what are they asking me for? Are they asking me for a change? Okay, I need to find the derivative. And so these are some of the common usages, and basically what we have here is for a rate of change is that an object moving along a straight line. And when we talk about movement along a horizontal line or a vertical line, we can get this thing that movement to the right is considered upward and in a positive direction, and movement to the left is downward and considered a negative direction. So this is over here, this is AP stuff. This is the way they're going to be asking you questions, and you need to make sure that you know this. And then the function that we start with is when we start with like an f of x function, like x squared, this is what we call a position function. It will tell me when I put in an x value, it'll tell me the position. It'll give me a y value that'll give me an ordered pair as its position. When we start dealing with the derivative, that's going to get me a change in distance over time, which is what we call our rate of change, or the derivative, or it'll give us what we call a velocity function. And so when the derivative function, when we take the derivative of this, this is the velocity function. It's another name for the derivative. So we have a ton of names for these things, and velocity, if you know anything about velocity, it's a change in distance over time. And so that's what we're talking about here. And then finally, velocity versus speed. Well, velocity, again, like I was just talking about, is there's two different types of velocity that we're going to deal with. Okay, there's instantaneous velocity or simple velocity. So if they just say find the velocity of a function at a particular point, this means derivative. Take f prime of x, find the derivative of the function and plug in that value, and that will give you that. It will give you that what they're looking for. But they also ask you for an average velocity, and an average velocity. Oops, and I didn't mean to cross it out. An average velocity is basically what we call the secant line, and this is the secant line that we're talking about. It's an average, and so that goes back to the slope that we all know and love from way back at the beginning here, where we do something like this, where we'd find the slope of the line, and then that will give us the average of what's going on there. And so when you hear average velocity, you have to think slope, like we were used to doing all the way up till calculus. And when you hear velocity, you need to think, okay, I got to take the derivative of this. And so again, this is our general rule for velocity. You can see that it is our limit process of our derivative. But as we do this, the limit process comes out to follow our rules that we are having, our patterns that we found when we were doing this. So a velocity is the derivative of a position function. The velocity can be positive, negative, or zero. Now speed, if they're asking you for the speed, they're asking you for the absolute value of the velocity. Because if you think about speed, speed is not directional. When you're driving your car, it doesn't matter whether you're going 60 miles an hour forward or 60 miles an hour backwards. If you are in a 30 mile an hour zone, if you're driving backwards 60 miles an hour, the police officer is still going to pull you over for speeding. So the speed is the absolute value of velocity. Speed is never negative, It's always a positive, and velocity is basically directional, and that's why it's positive or negative, and that's what we were talking about in the previous slide in that light blue box that I needed you to get down. And so then an object falls with a force of gravity looks like this, and this is a function that we're going to use, and eventually we will derive this function. We'll end up getting this function from stuff that we know, and so it is 1/2 gravitational pull times squared plus the initial velocity, which is v sub 0, times time, plus s sub 0, which is the starting position of the object. So how far above the ground? Was it on the ground? Was it? And you guys have seen this before in pre-calculus. And this is just a function that we need to know. And it'll go back and forth on what g is, whether it's negative 32 feet or 9.8, depending on whether we're dealing with feet or meters. And that's really all you have to pay attention to. And usually, if it's a feet question, s of t would be written as negative 16t squared plus v sub 0 t plus s sub 0. If it's a meter question, it'll be negative 4.9 t squared plus v sub 0 t plus s sub 0. So these are things that we need to make sure that we have, make sure that we understand. So if you have questions about these guys, please come to class prepared to ask them, and we will answer them for you.